Hello. So today we're going to talk about reflections, and we talked in Algebra 1 about how we translate or transform a line by giving it a slope or giving it a y-intercept. It shifts the graph up or down, or it vertically stretches it. There are different things that you did to those graphs, but today we're going to be focusing more on shapes. And so isometry has to do with a transformation that doesn't change the shape or size of a figure. And so the question is, what do you think of when you hear it doesn't change the shape or size? Well, that would be congruency. And so if shapes like the pre-image and the image, the shape originally and its resultant answer both have the same shape, that means that they're congruent. And we're going to be talking about transformations that keep the original, which is called the pre-image, and the result, which we call the image, congruent to each other. And so these are called rigid motions or rigid transformations. And so examples of rigid motions or congruency transformations would be a reflection. Okay, so this is a reflection where, if you look at it, it takes the original shape, which we call the pre-image, and it reflects it across a line. And the line of reflection is going to be a dotted line, and it reflects it either horizontally or vertically or diagonal. And that's one of the types of transformations we're going to be speaking of. And so then what we want to talk about would be a slide. Okay, slide, another name for that would be a translation. Okay, so if it slides it sideways or vertically or diagonally, that would be an option. And then thirdly, a rotation, okay, around a certain point, like the origin. So if you rotate a graph or shape, we can call that a rotation. And so this little fish or whatever shape it is rotates through space, and the beginning, the pre-image, and the image both are the same size and shape. They're both concurrent to each other. Examples of transformations that are not isometric or isometries would be a dilation. So something is going to be dilated or expanded. No, the original and the result, or the pre-image and the image, are not going to be congruent to each other. So these are not congruent. Instead, they're called similar. And so similar, congruent symbol looks like that, as you know, and similar looks like that. And so that would be proportional. And when you're in Algebra 1, you guys wrote proportions about things that could be solved in that way, and you cross-multiplied to solve them. And we'll do that later this year, but I just want to say, hey, here are some examples and here are some non-examples. And so getting into reflections, you have an original image called the pre-image, and that pre-image gets reflected across an axis or a line of reflection. And so here's your original, the pre-image, that's the original. And this result is going to be called the image. Kind of like if you watch a preview, that's like beforehand, and then like the actual movie is the movie. So the pre-image would be beforehand, and then the image is the result. And you can tell which one is which if they've labeled the ordered pairs on the edge. Look, this ordered pair here says it's point A, and if you see it, it just says A is this. Over here, it says A prime. Do you see that little pokey thing up by the A? Well, that means A prime. That means A, with result number 1, like after you've done one transformation to it. So B is point B, that's original, and then B prime would be after one transformation has happened. And so you got the original and you got the result, so the pre-image and the reflected image. And so each point on that pre-image has a corresponding resultant point, okay, of the image. So pre-image and then image. And notice each of the pre-image and the image that point is equidistant from that line of reflection. So this is like 2 away here and 2 away here. And so like this point is what, like 5? 1, 2, 3, 4, 5. And so again, the other point is 5 away from that reflection as well. So that's kind of something we're going to be looking at. In fact, on Delta Math, there's some really great things you can do there that I wouldn't ask you necessarily in person because they're harder if you can't move stuff on a computer. And so an example that would be over here on the right where they give you two shapes, and we're going to do mostly vertical transformations, reflections, or horizontal, and meet like a couple like diagonal, a line along the line y equals x. But if I want to get fancy, I will put on delta math. We're like, okay, I want you to find the axis of reflection. How you do that would be, it'll give you step-by-step in delta math. Like, okay, make a connection between a point and the result. So A and A prime. So again, this is the original, and this is going to be the image, the result. You make a dot between those, and it says, okay, connect all the points and the resultant image point. So you connect C and C prime, D and D, or B and B prime. And then it says, find the midpoint of each. Well, all you do is click kind of halfway. If you don't quite get halfway, it'll yell at you, but if it is halfway, it'll make a yellow dot. And you click halfway on each of these, and it says, okay, connect them. So when you draw a connecting line here, it draws the line of reflection. And so it's kind of cool to say, hey, they're at a right angle. You can draw things, you can do things in delta math perhaps that I wouldn't ask you to do in person, but it's still good to have that thought of like, how could you actually make that line of reflection or find it? And it's going to be perpendicular to the lines that join the corresponding pieces, the corresponding vertices. Okay. So on your pre-image, every point on that is named. And so like example, if one of them would be named A, and then that means that on the image, the corresponding resultant point would be called A prime. Okay, so A is the original, A prime would be after one transformation. Well, just like if you're making a car, you do multiple steps to that same automobile before it's done. Well, you might do step one, that might be A prime. If you did another transformation, let's slide it left 4. Okay, that could be called, that point would be like A double prime, and then A triple prime, etc. Okay, and you don't put A to the third. It's not A to the third part. That's just not it. It's those little hatch marks kind of denoting how many transformations you've done to this graph. I also want you to remember that we spoke about synthetic geometry where there's not a grid and you just kind of do math and shapes without a grid. We also are going to have analytic where you place the geometry shape on a grid so you can, more carefully find the measurements between points. And so we're going to do both of these with the transformations we're doing right now. So in the back, a first example would be, hey, let's talk about making these reflections, by hand. And so I will give you a piece of parchment paper. And if you are homesick, you can just grab a piece of parchment paper from your kitchen and cut a little square. And what you would do is you place the parchment paper over this piece right here, and it will help you as you are trying to trace this and reflect it. So if you actually draw on the top of your parchment paper in pencil, and you place it on here and use a ruler, and you kind of fill this in really carefully, and then you place on the top of your parchment paper, you darkenly fill in these things here very solidly with a pencil, because you're kind of going to make a stamp out of your parchment paper. Then if you flip over it, like place it on its tummy, and then you reline up this right here, when you retrace these vertices on top of the parchment paper, the pencil that's on the bottom of that parchment paper will also make like kind of a mark on your paper, and then you can remove the parchment and then connect the dots to kind of say, hey, look at this, looks good. Now mine does not look good. Okay, so, and you would name the resultant points as G becomes G prime, F becomes F prime, E becomes E prime, and H becomes H prime. And so you're going to just use your parchment paper to help you do that reflection. Again, how would you do it on this one over here? Well, you'd place your parchment over here. Okay, and we're trying to reflect it across this line here. And so you place it on there and you darkenly with a ruler color over this line, because this is kind of going to be your basis, and you darkenly bubble in the vertices of the shape you'd like to reflect, and then you pick up your paper and you place it on its stomach so that the part that you've written on is down and against your paper. And then if you line up this reflection line, and then you darkenly write on the dots that you see, you'll see that when you lift away your parchment paper, you will have a grid that you can fill in with your ruler to say, okay, this is the shape of it reflected. And so again, this would be P prime, this would be Q prime, this would be R prime, and this would be S prime, to be able to get your reflected figure across that line. And so remember, if you reflect it, it should be, kind of congruent. Mine is not because I really just made it up as I went. And as you look at this one right here is not going to be an example of a good reflection. Why? Look at the bottom of it. That doesn't match up at a bit. So this is not a good example because it's not congruent. This would be a good example of a reflection because they are congruent. Okay, so again, the original and the resultant shape should be congruent to each other. So off the grid, here are some examples of what we're going to do. However, on the grid, we're going to be talking about how can you take a point or how can you take a shape and on a graph, can we reflect it, first of all, across the x-axis, second across the y-axis, and third of all, across the line y equals x. And so let's look at these each here, okay? If you want to go across the x-axis, that's vertically, okay? So it's going to reflect your graph vertically. And so you're going to keep your x-coordinate the same, but your y-coordinate will be the opposite. So given your original point for every single part of your figure, this will be the same. That's the same, just kidding. And this right here is going to be times by -1. So if you keep the x the same and change your y-coordinate by times it by -1, every point, do that to it, is going to be reflected vertically across the x-axis. Okay, so we'll go down to the bottom and we'll do that first. Okay, so down at the very bottom, the second number 3, I didn't realize I numbered stupidly, but if you look at this, this is 3, 2. 3, 2 is going to be point x, and then 2, -2, that's going to be point y. This is going to be point z, and you can connect them with a ruler. Okay, and that's your pre-image. But to get the resultant figure, we're going to say keep x the same, okay, and change the value of y, times it by 1. So this is the same. This one is going to be times by -1. And I'm going to fill this in just because it's cute. If I fill this in, I'll see, okay, this is the original or the pre-image. And then to find the result, you're going to get x prime, you're going to keep x the same, and you're going to change the coordinate of y to be the opposite. So you get 2 and you get 2, okay? -2 becomes positive. You times it by -1. And then z was 4, and then the -5 becomes opposite, which is 5. So graph these points, 3, -2, and that's x prime. It's a little hard to label these, but you should try to. 2, 2, okay, that's going to be y prime. And then z prime is going to be 4, 5. That's up here, that's z prime. And so you connect these dots. I did not connect them very straight. I don't have a ruler, and I'm trying to hold my arm so it doesn't fall. But that would be the image. And notice it's reflected vertically. If you saw my hands, you'd see me like tumbling hand over hand, so that you would see that that reflects vertically across the x-axis. Okay, and normally you make a dotted line on the axis of reflection. So if you look up at the top, that's pretty common to say, let's reflect a graph across the x-axis and then also across the y-axis. So pretty basic things to reflect across. And so if you go across the y-axis, the directions for that are going to be, you change the value of x, you times it by -1, but y stays the same. So horizontally changes the x-coordinate, okay? And so across the y-axis is a horizontal reflection, kind of like turning the page of a book. And so if you go down to this graph right here, and it's the same original pre-image as the other one. Why? Because I just thought it'd be good to say, hey, given the same x, y, z, x being 3, 2, y being 2, -2, and z being 4, -5, the rule for reflecting across the y-axis is to change the value of x by times it by -1, and then keep y the same. Okay, and so how do you do that? Well, x prime would become -3, 2, y prime would be -2, and the y stays the same, and then z becomes -4 and then -5. Okay, and so you change x and y stays the same. And in graphing this, you would notice, yeah, it does. -3 and then 2 goes up here, and that's x, and then -2, -2, that's y prime. Okay, let's put prime in there. And then z would be -4, -5, and that would be z prime. And notice, hey, this is exactly the reflection horizontally across the y-axis, and you can graph the axis of symmetry, or the axis of reflection, okay, about which this has been reflected. So it's kind of cool to say you can just change either x or y to be opposite depending which way you want it to move. And so Go ahead and keep your notes handy when you're doing these. The other transformation we're going to do a lot is about the line y equals x. Okay, what's the line y equals x? Well, think about points that make that true. Points that where y equals x are going to be like 0, 0, 1, 1, 2, 2, 3, 3. That's the most basic of lines. And basically, it's the origin 0, 0, 1, 1, 2, 2. And this is going to be the axis about which we're going to reflect some lines. And the way you do it is this is my favorite, you switch the values for x and y. You just put x for y and y for x. And so these points are pretty fast. On the other ones, you just switch the sign of either x or y. And so below here, we're going to say, okay, here's my original shape. And it might be smart to connect these together. We start with r, which is at -2, 1. That's r. And then your next point is 1, 8. Okay, this is going to be s. So connect those. And then we got 1, 4. Okay, that's going to be t. And then the next one would be 4, 4. That's going to be u. And then v is here, and then back to r. So that's the shape. If you connect them in the order they gave you, that gives you the shape that you have. And so it says, okay, I want you to reflect it across the line y equals x. And so that line, and we can graph it, and we should, okay, is, the points 0, 0, 1, 1, -1, -1. So it's basically start at the origin, the slope of 1. And so we're graphing this line. And then we're going to actually find these points. So just flip x and y. That's how you come up with r prime, is you say, okay, let's flip it. Just switch x and y. S prime would be 8, 1. And then t prime would be 4, 1. And then u prime would be 4, 4. Notice that doesn't change, does it? And nor does v prime, 2, 2. When you switch x and y and they already match, you can't tell a difference. And so we plot these points, and we'll go start with 1, -2. That's going to be r prime. And then our second point is 8, 1. 8, 1 is here. It goes to 10, so just go over, almost over. And this is S prime. And then we can connect those. And then 4, 1, 1, 2, 3, 4, and then up 1. That's going to be the point T prime. And then our fourth point is going to be 4, 4. Well, we already did that. So V, or U and U prime are actually the same value. This green is really ugly, sorry. And so this is U and U prime, same thing because they're both from 4. And then 2, 2 is going to be V prime. So V and V prime are the same thing, and you go back to this. So if you notice, this has the original function and the image, the pre-image and the image reflected about the line y equals x. And so it's kind of cute. That's my favorite one. It's also called inverse when you get a little bit older. You do that with like whole functions. And it's just kind of beautiful how x and y switch and how the symmetry works and how the functions actually echo each other in a pretty way. Okay, moving forward, the last thing that we're going to talk about would be graphing across the line y equals -x. And so if you go to x equals -2, sorry, I said that wrong. You just graph the line x equals -2. Remember, horizontal lines are y equals, vertical lines are x equals. So graph it. And then I already plotted the points. So on your homework, you're going to have to plot your own points. And you can label those. And then after you're done, the one that, if it's not one of the 3 I gave you, you're going to just have to count. How do you count? You count, and remember that this original point of 2, 1 is supposed to, R should have a reflection point that's equidistant from this axis. And so it's 4 to the right of it. We'll go to the left of it and make your new dot, 4 dots. So 1, 2, 3, 4. So this would be R prime. So they're equidistant from the axis of symmetry. So this up here is S, or 2, 4. And so that's S. So how would you get S prime? Well, you go, again, equidistant from this axis. So this would be S prime. Okay. And then to get over to this next one, it looks like it's 2, 3, 4, 5, 6, 7, 8. Okay, from here, go over 8. We already went 4, 5, 6, 7, 8. So this would be, I guess, what, T prime? If this is T, this would be T prime. And you can kind of see the shape come together. This other one is just 1 below it. And so equidistant from this new axis, if it's something different, there really isn't a formula I'm going to teach you. There are formulas you could come up with. Somebody came up and told me one earlier. But what I would say is just make sure you count and say it's equidistant from the axis that you drew that you're going to be reflecting across. So x equals is a vertical line and y equals is a horizontal line. All right, thanks for playing. Bye.